Hi there. Today I'm going to show you how to build an ICO using Zeppelin solidity contracts and truffle framework. So let's get started. So I just created a brand new folder with nothing in it, and we're going to initialize the new Node.js repository. Everything just will be used as default, and now I'm going to install truffle framework. And then I'm gonna install Zeppelin Solidity as a dependency as well. So while it's installing, I'm gonna tell you what we're gonna do today. So we're gonna build a very simple crowdsale contract based on a crowdsale.solidity in a contracts folder. This one, which is using the mintable token. Let's see if we, okay. So now we're gonna open this folder in Visual Studio. Here we go. I'm gonna open terminal. And I'm gonna initialize our truffle repository as well. So since we installed truffle, I'm just gonna call truffle init, which we're also gonna initialize with the contracts folder and migration folder and truffle.js. So this contract will be using mintable token, which is based on this mintable token from Zeppelin. So you can, whenever somebody buys the token, it produces the total supply. It increases the total supply and adds the balance to the participant. So let's see. Okay, so now we're ready. So when truffle initializes it, we have few sample contracts, MetaCoin and ConvertLib. Since I won't need them, I will remove them from the repository. All right. And then our migrations folder also have some stuff that we don't really need. All right, so let's get started. We're gonna create our contract. It's gonna be called, let's say, blockchain labs crowdsale. Here, we need to define our Solidity version first to make sure we have the correct one. I'm gonna run the truffle version command, which is 0415, and I'm gonna paste this line, copy this, I'm just gonna say 15. That's the version that we have. That's the version that the truffle will be compiled with. And I'm gonna import Zeppelin contract, which is located in contracts, crowdsale. And I'm gonna copy this path and paste it here. Now we're gonna write our contract. We're gonna say contract blockchain labs crowdsale is crowdsale. Basically what that means is we inherited from the crowdsale contract, which is this one. And now we need to define our constructor, blockchain labs crowdsale. And here we're gonna provide some arguments. So I'm just gonna copy paste from the crowdsale contract here. These ones. because that since we're inheriting that, I'm just gonna use it. And in order to call a super on a constructor, we have to call it as a modifier, basically, crowdsale, and we are gonna pass every parameter to the crowdsale contract. That's it. Now we need to define our token contract. So in this contract, we have the method called createTokenContract, which says create the token to be sold, override this method to have a crowd sale of a specific mintable token. So I'm gonna copy this one. Sorry. And we're gonna specify our own mintable token. So here we're gonna say import a mintable token, which is token mintable token. And then, since we're not gonna use just default mintable token, we're gonna use our own. I'm gonna import it. Let's say blockchain labs token. Now we have to create it, and we're gonna pass it here. And now we're gonna create this contract. Blockchain labs token. And we're gonna do the same thing, except we don't need a crowd sale here. And we're gonna define contract blockchain labs token is mintable token. And then here I'm gonna pass some ERC20 properties. ERC20 is a standard on Ethereum network of asset tokens. So let's say if we look at the example of the simple token, we just need to have these three fields. So we can say we don't need actually 256.8 will be fine. And we can say blockchain labs token. And let's have a symbol of BLC. That is pretty much it. So now let's try to compile our contracts to make sure it's working, it's compilable. In the meantime, all right, looks like it's working. So now what we have to do is to write our deployment script in Truffle. So here we need to import our token contract. So basically, we only need to import one contract because we're deploying our token contract inside of a crowd sale contract. So whenever you deploy the crowd sale, it will automatically deploy token contract because we're using new keyword with our contract, which basically means please deploy this contract. So we need to import this contract. And here I'm gonna define a few things: network and accounts. This is basically come from your Ethereum node, whatever you're gonna run, you're gonna have these values set by your Ethereum node. So here I'm gonna basically return live deploy. I'm gonna pass deployer and accounts. And let's define this async function, live deploy with deployer and accounts. And inside of this function, we need to deploy our contract, which is a blockchain crowdsale, and we need to pass our arguments. So I don't really remember them, so let's copy this, and basically we can pass it here. Okay, so we need to have a few helper functions because we're using start time and end time. And of course, you might think that you can use date.now in JavaScript, but that's not the case here, because Solidity timestamping, it's not this. It doesn't have the same format as a JavaScript timestamp. So what we can do in the truffle, you basically have a Web3 object defined globally. So let's ask Zeppelin Solidity for help. They have some cool functions. The first one called latest time, which is basically similar to our date time. Let's just copy this function, and I'll call it, latest time. We don't need to export it. And the second one that we need is called Ether. It's if we want to define a cat. No, we don't need that. Sorry. We need to have increase time, I believe. Yes. Okay. So we don't need all of that. We just need this function. We don't need to export it. All right. So now we need to define our start time and end time. How we're going to do that? Let's see. Again, go to Zeppelin Solidity because I don't remember from the top of my head, and I'm not using any notes. So let's see the sample crowdsale. Let's see how they did it. They defined the rate as a big number. They have this big number. All right, let's define it. Big number, and then the rate is basically 10. So rate means how much your token will cost. When you say rate 1, basically 1 Ethereum will be equal to 1 of your own token. In our case, 1 Ethereum will be equal to 1 BLC token. Okay, rate, and then we need to have a start time and end time. Start time, end time, latest time, plus duration dot week. So our start time will be 1 week from now, and the end time will be only for 1 week. When it started, it's just our crowd sale will be running only for 1 week. So let's change it to constants. All right. So now let's paste these values. Oh, by the way, we would need to know our arguments at the time of the compilation. So I'm gonna say this is our array, start time, end time, our rate, and address. Address is basically we are gonna use the first account that we have. So basically this wallet means at the time of the crowd sale, where funds will be forwarded to. Usually people use some sort of a multi-signature contract, so then the team can manage this. Or you can actually, of course, just use a simple Ethereum address, but I would not recommend it, because if you lose your private key from the address, your funds could be hacked or stolen. So I'm actually not going to use a big number here, because when I do console log, I'm just going to pay some, we're just going to say 2 number. All right. So again, our first argument, start time, end time, rate, and wallet will be accounts 0. Okay. Let me pause it for a second. All right. So then we need to return this, we can say then instance of our contract. Then I would like to see await instance that deployed, and then instance and I would like to call token contract. We're gonna say await. Actually, we have to define it as a async function. Await instance token dot call. And we're gonna console log it. Let me see. All right. Let me see. Actually, I don't believe this is gonna give me an instance. So I suppose we need to call the blockchain crowdsale that deployed. It's just gonna have the instance, and then gonna have instance token.call. So then we can see the token address. Token address. Alrighty, so now I think we're ready to deploy. Let's give it a try. Okay, scary time. So let's see. I'm gonna run a local parity node against the colon chain. I have this comment. Basically, we're gonna run a colon chain. I'm gonna unlock my Ethereum address. This is the file with my password. This is not my actual password, it's just the name of the file, because it's 0039. That's how I keep track of them. So I'm gonna run the parity node. If you don't know what parity is, it's basically implementation of the Ethereum node. So go ahead and install it. It's very simple, very easy to install. You can use Geth, but I prefer parity because it's faster. All right, so parity is running. Let's deploy our contracts. Truffle, migrate. Looks like we have some issues. Let's see. Okay, how about if I don't use this rate? give it a try one more time. Let's see. So it's not a number and time. Oh, of course, because I had this typo. Sorry about that. Now it should be working. All right, looks like it's been deployed successfully. So let's see. Now I'm gonna go to colon chain. I'm gonna look for this address. And we are gonna verify this address. So in order to verify this address, you need to provide a contract name. This is our contract name. Our compiler, which is 15. The way you can see that is by, again, running the bin truffle version, which is 15. So optimization enabled. Now we need to flatten our contract. I'm going to use a repository called Oracle's Combined Solidity. So you can take a look at here from the Oracle's project. Check it out. Oracle's Combined Solidity, this one. It's run by oracles.org team. So it's very easy to use. Basically, we need to npm. Actually, let me do this. We're gonna have our ICO per week folder, and we're gonna have our crowdsale contracts, and our crowdsale is Blockchain Labs crowdsale. All right. So now we have to run npm start, which is gonna run some script. Here we go. Check our out library directory, this one, and I'm gonna copy this to the buffer. So now I'm just gonna paste it here. And we need to provide our arguments ABI encoded. So remember I told you that we have these arguments and we actually need to encode those arguments. So the way we can encode it is by installing web3. So if we're gonna go yarn add web3, that's gonna install the web3 library. And keep in mind that this is gonna install web3 1.0 version, which is very different from the previous versions with some breaking changes. And let me show you how we're gonna encode it. Web3 documentation. There is a web3 eth.abi, and they have a function called encode parameters, which you can put an array in it and your parameters, and you're gonna have the encoded value. So let's see. I'm gonna reuse node. I'm gonna say web3 equals require web3. And now we're gonna define our web3 instance, which will be new web3. And then I'm gonna provide a local host 8545. And now I'm gonna call this function ABI encode parameters. And first array is our types. So our first type, unsigned integer to 56. The second one, unsigned integer to 56. Basically, I just remember them because I've deployed this contract for some time. And unsigned integer 256, the first one, the second one, the third one, and then the address. So that's how I know. Unsigned integer 256, then the next one unsigned integer 256, and the last one is address. Now we need to provide our values. I'm gonna copy and paste them from here. Copy and paste. Whoa, what happened? All right, so I'm just gonna say var values, which is equal to this values. All right, so web3 ETH ABI encode parameters. Yep. Again, I'm gonna define it unsigned integer to 56, unsigned integer to 56, unsigned integer to 56, and address and values. All right, this is our encoded constructor that we need to paste in our Etherscan for verification purposes. So I'm going to remove 0x, and I'm going to click verify and publish. That should validate that your bytecode is matched against your compiled version of the code. So basically the Etherscan team, they are trying to compile the code that you provided, and all right, looks like it was successfully generated because the bytecode was matched. So now, as we can see, this is our values, parameters that we passed. And here we have our token contract, which we also need to publish. So I'm just going to use the exact same code that we already have, except that the contract name will be different. It's called Blockchain Labs token. We have the compiler. And since there are no arguments, we just click verify and publish. Let's take a look how we can participate in a crowd sale right now. Let me look at the code, because I don't remember if the, yep, so we can just use the fallback function to send the money just to the address in order to buy some tokens. All right, good. So we just verified our Blockchain Labs token. This is our values. Initial supplier, this is the owner. Owner is basically a contract, which is a crowd sale. And the owner of the crowd sale contract is, I mean, not the owner, the multi-signature wallet where the funds will be sent to. So let's buy some tokens. I'm gonna send the money to this crowd sale contract from my MetaMask. So I'm gonna say buy. No, not buy, sorry. I'm gonna send some tokens to this crowd sale. I'm gonna send 0.5 Ether because we're on a common chain. So next. Oh, I see why. Because yes, we cannot send it right now, which is good, because our crowd sale should start at this time, which is in a week from now. So we cannot actually start it. We cannot actually invest into the crowd sale right now. So we can redeploy the contract, let's do that. And let's say we're just gonna remove this line, and we are gonna redeploy that. We still have a parity running. And by the way, the Etherscan will be able to re-verify the code because we previously re-verified that. What's going on? All right, yeah, sometimes it just fails for no good reason. So let's see. All right. So now with this deployed contract, we should be able to participate in a crowd sale. So we have this address. Let's see the new address. As you can see, it was already verified based on the other contract we just verified. That's a cool feature from Etherscan. Thank you, guys. And now we have this token contract, which is also already verified, which is pretty cool. So we don't need to do any work. And now we can participate in the crowd sale using this address. So let's buy the token from MetaMask. I'm going to say send to this address 0.5. Let's see. I'm not sure what's going on with my MetaMask. 0.5. Maybe some bug from MetaMask, but okay. Looks like our transaction went through. And now we should be able to have some tokens. In order to verify that we just bought some tokens, we should be able to, what's our crowd sale address? Actually, token address. This is our token address. And I'm gonna say tokens, add token. This is our token address. As we can see, it was able to see this address and verify the token symbol. Click add. Let's see what's going on. This is our crowd sale address. So the crowd sale received my 0.5 Ether, and it should give me the some tokens. Not sure what's happening. Let me pause the record. Hi there. So I just paused the video in order to figure out what went wrong. The reason that it didn't work out because I was looking from the master branch at the Zeppelin Solidity, and basically in their latest code they're using the time in their constructor arguments, and when you add a Zeppelin Solidity at the NPM, it is not using the master branch, and the actual code is actually star block, end block, and rate. So that's why we were not able to get any tokens, because it simply fails. So let's see. It just says that the star block for our contract would be this block, and the current block of the Etherscan is 3,237,692. So, and the current block the start would be way ahead of this. So that's why we're still not able to participate in. So let's fix it by adding solidity at the master branch, because I really like using time instead of blocks. So we're gonna say npm install GitHub branch, because I don't remember how to do that. We're just gonna say, okay, we can do that, but I believe there is another approach. Okay. So let's go to our npm file and let's have this to be changed at Zeppelin solidity github.com Open Zeppelin Zeppelin.git branch master. Master branch. So now let's remove our node modules and let's install them. So that should install Zeppelin from master branch. Contracts, crowdsale. Here we go. Now we have time instead of blocks. All right, now let's redeploy our contracts and see how it goes. So now I have truffle, migrate, reset. All right, we are almost deployed our contract. Okay, so this is our crowd sale. We will have to again verify this contract. Oh, it's already verified. Interesting. Very interesting. That just doesn't make, okay. All right. Let's give it a try. I'm gonna buy some tokens. Let's send some tokens to this address 001. Okay, and this is the token contract. All right, I just debugged what happened. So basically, when you change your contract, you have to clean your builds. And now we are gonna have truffle to recompile them, and then we're gonna migrate it. And by the way, now we cannot use start time equals latest time, because in the contract there is an internal verification Zeppelin contracts. So we cannot use just the latest time. We have to have some minutes. So because it's gonna verify that start time should be equal or more than now. So because of some delays, let's have maybe by 1 minute. And then now we're gonna migrate it. Truffle migrates. We're gonna have to verify the contract because the source code of the contract has changed. So now I'm gonna, let's go to Etherscan. We need to re-verify the code, so the name would be blockchain crowdsale with the 15 version, and then we're gonna use again our really cool tool built by Oracle's network. All right, then copy paste it here, and now we're again need to revalidate. Compile our arguments. We can actually do it right inside of here, so we don't have to jump back and forth. So here we're just gonna say values equals these values, and then we're gonna run our web3. All right, this should be our new values. And we need to pass them here. Verify and publish. Let's hope for the success. All right, it worked. All right, okay. So now we're gonna try to, let's see if the token has changed. Yeah, it also changed. So now we're gonna try to buy this ICO because I really wanna buy this token right now. And let's see if this is gonna work. Send 0.01. Next. All right, looks like this is gonna work because Truffle doesn't complain. And now this is our token address. We're gonna verify that we just bought some tokens. All right. Well, the MetaMask doesn't show us because we bought it with a very small amount. So if I buy it with my account, and we're gonna send it to this 47. Sorry. Send to this address. We're gonna buy 1.02. And since have the wallet redirected to my account, so I'm just gonna send it to the contract, buy some tokens, and I'm gonna provide this address. Here we go. Once again, let me make sure. Yep. So that's it. looks like it's working. So if you just want to revalidate the new contract, our new token contract, with the name of, what was the name? The name was Blockchain Labs token. I'm gonna paste the same code, click verify and publish, and we are all done. Okay, yeah, it works. So once again, let's buy some tokens one more time. We can go to our crowd sale address, which is this one. We can go here. Actually, we can send this address. I'm gonna send 1.2. Next, submit. Let's give it some time. Okay. All right. Now we have 2.4 blockchain labs tokens. Thank you very much for your attention. Enjoy.